Hi guys, today we're going to be looking at the inverse of a function. We've got a fairly simple example. We want to find the inverse of f of x equals 3x minus 2 over 2x plus 3. Here's the process that we use to find the inverse of any function that is one-to-one. To find out if a function is one-to-one, you basically just need to graph it and see if it passes the horizontal line test, but we'll see the graph of this one a little later that it does do that. Once it's one-to-one, we can just take our equation of our function. Everywhere we see f of x, we're going to replace it with x. Everywhere we see x, we're going to replace it with f inverse of x, and then we'll have an equation that we're going to solve for f inverse of x, or we're going to isolate f inverse of x on one side of the equal sign and move all the other terms over. So here is our function once we make our substitutions. We've got an f inverse of x and an f inverse of x in the numerator and the denominator of this fraction. So we're going to have to come up with a process to isolate just f inverse of x on one side of the equal sign and everything else over. So here's how we do that in this case. We're going to multiply both sides by the denominator. That will clear the denominator on the right side, and we'll have to put it in parentheses on the left side that gets multiplied by that x. After that, we're going to distribute this x through this parentheses. That'll give us 2x times f inverse of x for the first term plus 3x for the second term. The right side remains the numerator of that fraction. And now we're going to collect what we consider to be the like terms of the f inverse of x on the left side. So we're going to take this term, subtract it from both sides, and then we're going to take this term and subtract it from both sides because it does not contain an f inverse of x, so we want to move it over to the right. So at this point we're going to factor out an f inverse of x from both terms on the left side. All that's left from each one would be a 2x and a minus 3, and the last bit we're going to divide both sides by this 2x minus 3 to move it over, and that should leave us with just what we wanted on the left side, our f inverse of x. So f inverse of x is equal to negative 3x minus 2 over 2x minus 3. That's our inverse function that we're hoping for. And the way that we check our work is to graph both curves and the line y equals x. Remember that a function and its inverse should be like a mirrored reflection across the line y equals x. So let's go ahead and do that and see what we get. So here is the line y equals x. I draw it in dotted line because it's not really a part of our graph. It's just something that we use to measure other graphs by. So here is our original function in red here. We're hoping that the graph of our inverse function will be the mirror image of this function across this line. So this curve of the graph will hopefully be right close to the line y equals x on this side, and this one will be pretty far away down here. So let's go ahead and add the graph of our inverse function, and sure enough it is. So this this leg here of the curve is reflected here, and this leg here is a reflection of this leg. So if you graph your inverse function and your function on the same graph, you can easily check to see if you have the right inverse function. If you don't, it's very likely that you missed a minus sign somewhere. I actually did on this example, and when I graphed it, the graphs were off, and I had to go back in my computations and figure out where I made the mistake. So graphing your inverse function is a great way to check your work. That's all for today.